Section 6.3, Graphing Linear Equations. In Section 6.1, we talked about finding different solutions for two-variable equations. If you remember, we discussed that two-variable equations have an infinite number of solutions, and we worked on finding up to 4 different pairs of solutions for each equation we discussed. Mathematicians, though, are interested in finding all the solutions for a given equation, so just finding 4 isn't really good enough. Because of that, mathematicians make a graph of the solutions, which then can be used to show all the possible answers. This section will explore in detail how to show all possible answers to a two-variable equation. The first example of a linear equation that we will look at graphing is x plus y is equal to 5. Remember, back in section 6.1, we had talked about setting up a t-chart. So you could set up a t-chart and let x equal any number that you wanted to. If x is equal to 0, y is equal to 5. If x is equal to 1, y is equal to 4. I'm going to put down a few more possible answers that we could have for x and y. So now I have 4 different possible answers. Remember that each one of these answers I have written right now into a t-chart, but I could also write them as an ordered pair. So I'm putting them in blue right now as an ordered pair, 0, 5, 1, 4, 2, 3, and 3, 2. If I wanted to show all the possible values for this particular equation, all I need to do now is plot these points. So I have the point 0, 5, and I'm going to put a dot at the point 0, 5. Another point is 1, 4. I'm going to go over 1 and up 4, and I'll put a blue dot on 1, 4. Another dot, or another dot that I need to put down, is at 2, 3. So I'm going to put a dot on 2, 3. And then finally, I can place a dot at 3, 2. Now, of course, I just put down 4 of the points that satisfy this particular line. There are an infinite number of other ones. The important information about this now is on the graph. And now all I need to do is draw a straight line through all those points. And as I draw a straight line through all those points as best as I can, you can see I'm going to put arrows at either end. What's important to realize is that every spot on this particular line is a solution for this particular equation. So I didn't do a great job of drawing this, but you can see that I have this particular point right here, and it looks like it crosses at the point 5, 0. Well, 5, 0 is a solution for that. Every single point that this line crosses, every single coordinate pair that this line crosses, is a solution. It looks like right here, this point, 7, 2, negative 2, I'm going to put a dot right there, it's 7, negative 2, also is a solution. And if I put 7 in for x and negative 2 in for y and add those together, I do get 5 for an answer. So what I've done is I've gone through and I have shown all the possible values for x plus y is equal to 5 by drawing that line. Here's another example. 2x plus y is equal to 4. One way to go through and graph this is once again to go through and set up a t-chart. So I'm going to set up a t-chart with x and y, and I am going to let x equal different numbers. If I let x equal 0, then I would have 2 times 0, which is equal to 0, plus y is equal to 4, which means y would have to be 4. If I let x equal 1, then 2 times 1 is equal to 2, so I would need y to equal 2, because 1 and 2, the coordinate pair 1, 2, is a solution for that equation. I'm going to do one more if I let x equal 2. if I let x equal 2, that means 2 times 2 is equal to 4, which means I already have my 4, which means y would be equal to 0. So now I have 3 points, and I'm going to graph both of those. The first is at 0, 4, so I'm going to put a dot at 0, 4. The next point is at 1, 2, so I'm going to put a dot at 1, 2, followed by a dot at 2, 0. Once again, notice that the dots form a straight line. And if I go through and graph these, draw a line through these as best as I can, and then put arrows at either end, I would have all the possible solutions for that. Once again, you can take a look at some of the different spots that the line goes through. And my line isn't perfectly straight. I can't really do this using this application right now because the ruler doesn't work for me. But I put a blue dot on that particular point, which would be the point -1, 6. So if x is -1, y must be 6. And if I put a -1 in for the x, and a 6 in for the y, and solve this equation, it's 2 times a -1 plus 6, I do get an answer of 4, so I can see that that works. So I'm able to come up with an infinite number of answers just by finding another point where that line crosses on this coordinate grid. Before continuing, I want to talk with you about the two different equations that we've graphed so far. X plus y equals 5 and 2x plus y is equal to 4. Both of these linear equations are written in what's known as standard form equations. And if I am going through and graphing a standard form equation, I really do it a different way than the way that I just got done showing. I want to talk about that for a minute. First of all, they are known as standard form equations. In order for an equation to be in standard form, one side of the equation has the x and the y in it, and you can see that the left-hand side of both these equations have the x and the y in it, and the other side just has a constant. So these are standard form equations. When we went through and we graphed that x plus y is equal to 5, and I'm going to put this information down again, x plus y is equal to 5, I started with the t-chart, x and y. And what I said was, choose a value for x and then solve for y. When doing a standard form equation, it's always easiest to choose the same value for x and then also the same value for y. If I let x equal 0, what that does is that then when I go through and solve it, it really gets rid of that x. I don't have it. So I just have y is equal to 5, which means that if x is 0, y is equal to 5. Then I let y equal 0. As soon as I let y equal 0, what that does is it gets rid of my y. If I could erase it, there we go. And now I just have x is equal to 5. All you need are 2 points to draw a straight line. So I would go through and put in these 2 points, the point 0, 5 and the point 5, 0, and then I would draw a straight line between those. When I do 2x plus y is equal to 4, I would go through and do the same thing. I'd set up a t-chart, x and y, and I would let x equal 0. As soon as I let x equal 0, that gets rid of the 2x, because 2 times 0 is 0. I just have an answer now of if x is 0, y is equal to 4. Then, if I wanted to let y equal 0, I'm going to put my 2x back in here that I had. Now y is equal to 0. So if y is equal to 0, it gets rid of the y. I have 2x is equal to 4, which must mean then that my x would be equal to 2. So once again now, I would have 2 points. I would have the point 0, 4, and I would have the point 2, 0. I would put dots at both of those coordinate points, draw a straight line, and since all I need is 2 points to draw that straight line, I would have a line that would work. So let's take a look at this equation, 3x plus 4y equals 12, and graph it in the same fashion. First thing I'm going to do is I am going to set up my t-chart. I'm going to let my two top labels be x and y, and I'm going to let x equal 0. As soon as I let x equal 0, 3 times 0 is 0, so I really get rid of that. And now I'm just left with 4y is equal to 12. If 4y is equal to 12, that must mean that y is equal to 3. I'm then going to let y is equal to 0. When y is equal to 0, let me put back the original equation I had, 3x plus 4y is equal to 12. Now, when y is equal to 0, 4 times 0 is 0, it eliminates that 4y. I get 3x is equal to 12, which then means that x is equal to 4. So my original equation, 3x plus 4y is equal to 12, I now have these two coordinate points that must be true. The coordinate pair 0, 3, and also the coordinate pair 4, 0. So I'm going to put those points on my graph. The point 0, 3, I'm putting a point right there right now at 0, 3. Another one is at 4, 0. All I need is 2 points in order to go through and graph that. And now I could connect those 2 points. I would use a straight line or a ruler I should say, when I go through and do that. Once again, I can't really do it on here. I'm going to put in a couple other points here that I know would fit for this. At least one other point, trying to get as straight line as I can possible as I go through. And I would draw my line, and my line would look similar to this. By the way, there are names given to these 2 different points where my line crosses the axes. This particular point where it crosses the y-axis, it's known as the y-intercept point because my line, 3x plus 4y, crosses the y-axis at that particular point. It intercepts the y-axis. This point, the point 4, 0, is known as the x-intercept. So when graphing an equation that's written in standard form, like 3x plus 4y is equal to 12, I go through this particular process, let x equal 0, solve it for y, let y equal 0, solve it for x. What that does is it then gives me my y-intercept point and my x-intercept point, and then I can just draw a straight line. Here's another example. 3x subtract 2y is equal to 6. What I'd like you to do is I'd like you to turn off this video for a moment, see if you can go through and graph it in the same manner that I just did the last one, and then turn it back on again and watch me as I go through and do it. Okay, hopefully you've been able to go through and you've been able to graph this. And let me talk through the steps. As I'm going to go through and graph this, I am going to set up my t-chart with x and y as the headings. The very first thing I'm going to do is I'm going to let x equal 0. And as soon as I let x equal 0, that means 3 times 0 is 0, so this is going to disappear. So now I have negative 2y is equal to 6. I need to go through and solve that for y. In order to go through and solve that for y, I'm going to have to divide both sides by a negative 2. If I divide both sides by negative 2, I'm going to end up with an answer of y is equal to negative 3. So one of the coordinate pairs will be the coordinate pair 0, negative 3. Next, I would go through and let y equal 0. Now, when I let y equal 0, let me go back here for one moment and get rid of the things that I had put in here and put back the original equation that I had. The original equation that I had was 3x subtract 2y is equal to 6. So now I'm going to let y equal 0. When I let y equal 0, that means that 2 times y is equal to 0, which means I'm going to be getting rid of this. So now I have 3x is equal to 6. If 3x is equal to 6, that means that x is equal to 2. So now I have these two different points, the point 0, negative 3, and the point 2, 0. I'll go back and put what I had in here for my original equation, and now I can go through and put in those two coordinate pairs. One of the points that I have is the point 0, negative 3, which would be right here where I'm putting my dot. The other point would be at the point 2, 0, which should be right here. And then I would go through and I would graph this particular line, and I would try to make it as straight as I possibly can. When I go through and do that, I'm going to put another point that I know that it would go through just to kind of help me out get a straight line. And my line and your line should look similar to that. There are two other ideas that you need to be aware of in this particular section. I have the equation x is equal to negative 2. Notice I don't have a y in that particular equation. If I wanted to graph that equation, I can go through and set up a t-chart again. And I'm saying that x is equal to negative 2. Well, if x is equal to negative 2, I don't say anything at all about y. So y can be anything that I want it to be. I could say y is equal to 0. Or I could say if x is negative 2, y is equal to 1. I could say if x is negative 2, y is equal to 5. I'm not putting any parameters on y. I'm just saying x always has to be equal to negative 2. If I wanted to go through and plot these points, the point negative 2, 0 is right here. I'm putting a dot on the graph. The point negative 2, 1 is right here. The point negative 2, 5 is up here. Notice that x always has to be equal to negative 2, but I don't care what my y is. So what I really have is I have a straight line that is vertical and is parallel to the y-axis. If I had y is equal to 3, it's the same type of thing. I'm going to set up a t-chart x and y. I'm going to say y is equal to 3, and I don't care what x can be. Once again, x could be 0, or if y was equal to 3, x could be 1. If y was equal to 3, x could be negative 4. I can pick anything at all that I want to. If I go through and I graph these points, 0, 3 would be right here. I'm going to put a dot on 0, 3. 1, 3 would be this particular spot. Negative 4, 3 would be this particular spot. And drawing a line through those points gives me a line that is parallel to the x-axis. It's a horizontal line. So you are going to see some problems in this particular section where you just have x equals or y equals. Just remember, if it's a y equals, you are going to end up having a horizontal line. If it's an x equals, you are going to end up having a vertical line. Being able to graph linear equations written in standard form is a very important skill in this class. There are all sorts of practice problems in the book you can look at to practice your skills. As always, please be sure to ask me for additional assistance at any time. Thank you.